Hello, welcome back to the Agile Basics video series. This is the first part, build in quality. I hope you've watched the introduction. I don't need to introduce myself again. Let's start by defining what we mean by quality. Software contains many qualities, some of which are desirable and some of which are not desirable. If you think about it, I'm sure you can name a few. Here's some I can think of. Maybe they correspond to what you're thinking of. Maybe there's some more. I think quality, all these qualities, they form an onion, by which I mean it's layered. They can nest within one another. So, you may have performance, you may have ease of use, you may have some more things. And they may differ from one product to another. They may differ at different times. I encourage you to think about what are the qualities you value in your software. And here's some homework for you. Gather your team together and draw your own quality onion. What are the qualities that are important to you? That said, I think there are two universal qualities for any piece of software which we regard as high quality software. I think there are two universal qualities we look for in it among many others. Two are always there. The first is few bugs. I'd rather there was no bugs, but I'm prepared to accept that there might be one or two. But I find it hard to think of software which has a lot of bugs, a lot of defects, a lot of rework that needs doing, that we would consider high quality software. I can't think of an example. I don't think one exists. So I think if you want a piece of software to be high quality, you need a limited number of bugs, few bugs, preferably, as many as you can count on one hand is about the maximum, maybe. And the second attribute I'm looking for, I think is universal to all software, is maintainability. I think if it's not maintainable, first of all, you can't get the bugs out there in there, you probably can't find them. But secondly, the software can't change. And successful software changes over time. As people use it, as people want more from it, as the world around it changes, it needs to change. So for me, for any piece of successful software, which we call high quality, these two attributes are at the center of our quality onion. Other software will have other attributes at the outer layers, but these two are always universal and always at the core. Independent of Agile, independent of most other software development methods, Capers-Jones has been looking at the statistics on software development for 30 or 40 years. He's unequivocal. He says this: the cost of repairing defects is the most expensive single activity in software development. Defects are expensive. Think about the initial writing of the bug, the finding of it, the reporting of it, the management of it, the administration of it, the scheduling of a fix, the retesting, possibly more testing and more fixing, let alone the cost to shut your support desk, the costs it may cause your business or your client's business when the defect shows up. Defects are expensive, very, very expensive. But that's not all. Defects destroy schedules. We get to the end of our schedule and we've got this defect list which we need to fix, and we don't know when we'll be done. Any schedule we start with, if we don't build quality in, we're going to be losing time. All the time we're finding defects, we're needing to fix defects. Defects destroy predictability. Even if you start off with a great schedule, as you find the defects are very difficult to estimate. Defects are very difficult, very variable rather, in how much time they take up. Any predictability you've got is lost when you have high defects. The other thing is defects destroy trust. When people use your software, your application, and it doesn't work the way they'd expect it to work, when it doesn't work the way it should work, when it crashes on them, when it gets in their way, and if they are people who are paying for this software, the fact that the defects have made it more expensive destroys trust. And if there are people who are waiting for your software and you didn't make the schedule, it's going to destroy trust. And if there are people you promised it to and you turn out not to be predictable, it destroys trust. Defects destroy trust in all sorts of ways. If you do nothing else, whether you adopt Agile or not, simply improving the quality of your software, reducing the number of defects will improve your software development. High quality, by which we mean few bugs, makes for shorter schedules. That's our mantra. Now, it's very easy for me to say this, and I'm sure a lot of you didn't need me to say, you're already convinced about it. The question is, how do you do it? Easy to say, more difficult to do. Well, here are some ideas. First of all, here's some hygiene factors I want you to think about. I expect many of you, if not most of you, are already doing these topics. If not, please think about doing them. Believe it or not, there's still companies out there who don't do the things we're talking about here. Number one is source code control. It may seem incredible to you, but there are still companies out there who don't put their source code under source code control. It's particularly prevalent with SQL code. Just because it's not Java or Python or Objective-C, just because it's SQL doesn't mean it escapes source code control, everything. And when you've got it under there, automate your build process, particularly if it's a compiled language. Have an automatic build process that can combine your software into a releasable product. And run that process regularly, at least every night, preferably far more often. If you can build it, and if you build it regularly, you will know you can continue to build it regularly. And when the build breaks, fix it quickly. Don't let breaking builds sit there for days, hours at most. Preferably, as soon as you see it's there, somebody fixes it. Add in static analysis tools to your build process. There's lots of static analysis tools for just about every language now, and they can pick up defects very quickly, very cheaply. Add them into your build system. And when you've got source code control, limit the number of branches you have. I'd rather you didn't have any branches, but at least limit the number of branches you have. And those branches should be short-lived branches. They're not branches that exist for days or months anymore. They're branches that exist for hours and days at most, and you're always bringing them back in. When you've got the hygiene factors in place, then think about these. Designing for the future. Don't do it. Design for here and now. Stop second guessing what might happen in the future. Design for where you are today. The future is unpredictable. We'll deal with it when we get there. Code reviews. If you're not already doing code reviews, please look at doing them. They are one of the most effective ways of finding defects in software. They don't have to be heavyweight Fagan-style inspections with lots of people taking lots of time. Simple, lightweight code reviews will give you most of the benefits for a fraction of the cost. Next time you have some code that you think you can check in, just tap somebody on the shoulder and say, "Can you review this for me, please?" When you've got your build system set up, you're continuously integrating code. You've got your little branches, you've got your little repositories. Continually bring it back to main. Check that it's working with everything everybody else is doing all the time. Pair programming. I don't want to say a lot about pair programming. I know a lot of developers don't like it. I'll probably put a lot of people off. Pair programming is where you have two programmers sitting at one keyboard, one screen, or maybe increasingly two screens these days, but they're working with the same piece of code. And as they're working, they're talking. One will write some code, the other will suggest some changes to it. They'll take the keyboard, they'll make the changes. Maybe one writes the tests, one writes the code. They swap around regularly. I'm convinced it's a far more effective, productive way of working. I'm convinced it leads to fewer defects. Not everyone's convinced by this. I think you have to try it for yourselves and see. Hopefully one day you'll try it. Until then, I'm not going to try and force feed you on pair programming. I know some people don't like it. And let's get away from reusable code. Let's stop making code reusable on a speculative basis. The time to make code reusable is when you actually come to reuse it, not when you're writing it the first time, but when you come to reuse it the first time. That's when you pay the cost of reuse, and you pay just enough for that reuse. Which brings us to testing. It's worth saying quality is not about testing. We confuse quality and testing frequently. It's very difficult to test quality into a product. Having high quality should reduce the amount of testing and the time we spend testing. One day we'll get there, one day we might eliminate testing, but for the moment, we still need to have testing in the picture. The mantra with testing is automate, automate, automate. When we talk about automated testing, people are very quick to point out what can't be automated. It's true, not everything can be automated, but the time to worry about the stuff that can't be automated is when you have high levels of automatic test. Until you get there, don't worry about what you can't do, concentrate on what you can do. Make the testing automated, make it fast, make it frequent, you'll get the feedback all the quicker. Automated testing will in the long run be cheaper than manual testing, but that's not what we're really after. Automated testing will be faster than manual testing. That's necessary, but in itself it's not what we're after. What we're after is the feedback that comes from doing rapid, fast testing close to when the initial work is done. And that nicely brings us to test-driven development, also known as TDD, test-first development, automated unit testing, and design-driven development. In many ways, I'd rather we called it design-driven development. Test-driven development is not test in the same sense of post-development testing. It's very involved with the developers doing the initial work. Test-driven development is writing code to test code. If you're writing in Java, your test code's probably in Java. If you're writing in Python, your test code's probably in Python. If you're writing in JavaScript, your test code's most likely be in JavaScript. It's for developers for developers. It's for developers for themselves. It's for their fellow developers, for the developers who come after them. It's for today, the work the developer's working on now. It's for tomorrow. It's in the changes they will need to make to their code tomorrow. And it's forever. The tests stay with you. The tests are there for as long as the system is there. The tests are integrated into the build system. They run regularly. They are 100% automated at this level. There is no such thing as a manual unit test anymore. And there's thousands and thousands of tests which are executing in microseconds. You keep the automated unit tests really fast. I'm not going to go into this study in detail. That could be 10 minutes by itself. What I want to say is this study is out there. It's one of the better studies for my money. They looked at several different teams. And as you can see, the teams that applied test-driven development significantly reduced their number of defects. Yes, it took the developers some more time to do the work initially. What that increased time metric does not record is the time that was saved elsewhere by testers, by managers, by customers, by support desks, etc., etc. This study purely looked at developer time. I will accept that it may take developers a little bit longer to work in a test-driven fashion than in a non-test-driven fashion, particularly when they are learning test-driven development. Unfortunately, we have a generation of programmers who really, many of them don't know how to do test-driven development, and they need to learn how to do test-driven development. So while they're learning, it takes longer. Once they're proficient, it may still take a little bit longer to write the initial code, but overall, I believe we'll save time. And once you've got test-driven development, then start to look at behavior-driven development and acceptance test-driven development. And there's more techniques out there for you to look at. There is methods, tools, techniques out there which you can use to improve your quality. We've talked about a few here, there are more. So our mantra is invest in technical practices and save money. Spend a little bit of money to save a lot of money. Hope that gives you an idea of why quality is important, and it gives some ideas on what you can do to improve your quality. Thank you very much for listening. If you've got any questions or comments, please email me at the address there. The next in this series is going to be visualize. Once again, thank you very much.